don't know if my mic's on. All right, lesson 60 in calculus. This is asking us to find the area between two curves. All right, for this area between two curves, let's say we have f of x is here, and we'll put g of x here. G of x here. All right, so when they ask for the area between two curves, all right, this is A, and this is, pretend this is B. This is B. They're asking us to find this area right here. Well, just from looking at this, well, what's the area, what's the integral from A to B of f of x? Well, it's this whole region right here, right? This whole thing. And what's the integral from A to B of g of x? Well, it's this section. So what's left over when I take f of x minus the integral A to B of g of x? That's the area between two curves. All right, so when we do these, the key to these is always going to be knowing which one's above. Okay, let me review something with you real quick. All right, when we say the integral from A to B of f of x dx, all right, remember this came from our Riemann sums where we have all these different rectangles of different heights. Well, the width of each of these rectangles, we've replaced with dx. All right, this is the dx, that's the little itty bitty width as dx goes to 0. Now f of x represents the height. See right here, this is f of b, this is f of a, and this is the y value. This height is this f of, I don't know, call it c, f of c. This height is the f of x. So the integral from a to b, add up all the little rectangles between a and b where the height is the y value and the width is dx. All right, that's what the Riemann sum tells us this integral is defined as. Okay, now again, the key to these is to know which one is above, which function is above. Now I wanted to show you this real quick. It doesn't matter whether they're both positive, whether one's positive and one's negative, or whether they're both negative. It's always the upper, whichever one's above, minus whichever one's below. That gives you your height. Instead of f of x, it's the f of the upper minus f of the lower. So in this case, 6 minus 2, this would have a value of 4. And in this case, 3 minus a negative 1, this would also have a value of 4, right? Because see, this one was 6 minus 2, that's your 4. This is upper 3 minus the lower minus negative 1. That gives you a height of 4. Well, what about if they're both negative? How's that going to work? Upper negative 1 minus a negative 2, look at that. The height is 1, and we know that this height here is 1. So for these functions, it doesn't matter if they're both positive, if one's positive, one's negative, or if they're both negative. The height, right, the height is always the upper minus the lower, and then the width is going to be our dx. So the value of the upper function minus the lower function, and our width is dx. All right, let's look at an example real quick here. In this example, this asked us to find the area between two curves on the integral 0 to 1. All right, so the first one is x squared plus 2. First one is x squared plus 2, and the other one is negative x. Well, x squared plus 2 is a parabola that starts like this, all right? And g of x, should have changed colors, g of x is negative x, so it looks like this. G of x is negative x, slope of negative 1. It looks like this, all right? Now it's asking us to find the area between the curves on the interval 0 to 1. So here's x equals 0, here's x equals 1. So it's right here. We're looking for this shape right here. Okay, everybody see that? It's kind of this shape. Okay, so when I think of these as my little rectangles, right? They all have a width of dx. They all have a width of dx. Well, the bounds are given to me. The bounds are from 0 to 1. And I wrote dy. That's interesting. Why did I write dy? Okay, it's supposed to be dx. Pen. Dx. All right, so my width is dx. My bounds are 0 to 1. What's this height? Remember, rhyme and sum, it's the width times the height of each of my rectangles. Well, the height is the upper function minus the lower function. In this case, x squared plus 2 is always greater than negative x. So we know the first function, x squared plus 2, is always above the bottom function. So it's going to be x squared plus 2 minus a negative x. All of this, that's my height times my width. This is my height. This one's my width. Height times width, that's my integral. So when I simplify this, it becomes the integral from 0 to 1. X squared, I'm going to put it in order, minus a negative is plus an x plus 2. That's the height times the width. Integrate this very quickly. And I'll get 1/3 x cubed plus 1/2 x squared plus 2x on the interval from 0 to 1. Put in your 1, so that's 1/3 plus 1/2 plus 2 minus 0 plus 0 plus 0. I don't really have to do that, but I'll do that for you. So 1/3 plus 1/2 plus 2, 2 and 5/6. 2 and 5/6. All right, so that's the area, or here, 2 and 5/6 square units. That's the area where my height is the upper function minus the lower function. My width is dx. My width is dx. Now see, the key to these is going to be graphing them. All right, the key is going to be able to graph them to know which one's above the other. All right, let's look at this example. All right, a lot of times, well, here I'll show you. There's an example in your textbook which I did not put together. I did the second one. But it takes these two functions, 2 minus x squared and g of x equals x. So let's see if we can graph these. All right, 2 minus x squared. Come up here to 2, and I'm going to cross, here's negative 1, 1, 1. All right, I'm going to cross at square root of 2. Right, negative square root of 2 and positive square root of 2 makes f of x 0. So this one looks like this, right there. And y equals x, so that's a 1, 1. Oops, that's a 1, 1, 2, I think. 1, 1, no, not that color, this color. 1, 1, and then down here. So, normally, when you see these problems, they're going to ask you for this area right here. They're going to ask you for the area enclosed. Well, to do that, you're going to have to find your 2 points. Well, how do you find where two functions intersect? You set them equal to each other. 2 minus x squared equals x, or 0, equals x squared plus x minus 2. This factors 2x plus 2, x minus 1. So that's how I knew they were intersecting at the point x equals 1 and at the point x equals negative 2. All right, so those are the points. Normally, then you would just take the integral upper, which would be the pink one, 2 minus x squared, minus lower, from negative 2 to 1, and that would give you the area between the curves. But this one didn't ask for that, did it? It asked for the area. Let me erase these. No, maybe I won't erase those. Oh well. This one asked for the area from the interval 1 to 2. Well, that's different, right? That's very different. They're asking me the area between the curves between the point 1 and the point 2. So that is this region right here. All right, that should be a straight line. That is this region right here between the point, area between the curves between 1 and 2. All right, so the integral from 1 to 2, upper, which one's upper, x, minus the lower, which one's the lower, 2 minus x squared. That whole thing, this is my height, right? This is my height times my width, dx. The value of x minus the value of 2 minus x squared. That's the height of this little rectangle in here. The width is dx. The width is dx. So simplifying this, we get the integral from 1 to 2. Let's see, minus a negative makes it a positive. X squared plus x minus 2. Put that there. Dx. Let's see. I think I integrated this someplace. Maybe not. Okay, so 1/3 x cubed plus x squared over 2 minus 2x from 1 to 2 equals, what's it equal? I'm out of space. Let me bring it up here. Equals 8/3 plus 4 over 2 is 2 plus 2 minus 4 minus, now put in a 1, 1/3 plus 1/2 minus 2. So this makes 8/3 minus 2 minus 1/3 minus 1/2 plus 2. So those guys cancel. 8/3 minus 1/3 is 7/3 minus 1/2. So that's 14/6 minus 3/6. Gives me a value, final value of 11/6, and that is correct, 11/6. All right. Again, there's an example in your book where they find this area, I'll shade it in yellow, this area right here, which is just the integral from -2 to 1. How do we know that? Because we found the points of intersection, -2 to 1, upper, which is 2 minus x squared, minus lower, which was x, all of that times dx, and that gives you the area of this yellow region. But this particular problem asked us for the area between the curves on the interval 1 to 2, so that's this blue region here. All right. Okay, a couple more examples, I think, yeah. Okay, one more example by hand, and then we'll do one with the calculator. Okay, this one asks for the region enclosed by y equals x squared and y equals 2x squared minus 4. All right, so this time, put this over here so I got a little more room. Y equals x squared, got that one. Y equals x squared, that one looks like that. What about y equals 2x squared minus 4? Well, at 0, it's down here at -4. X equals 2. Where is it? Well, I'm going to set them equal to each other anyways. So let's find out. So x squared equals 2x squared minus 4. So negative x squared equals -4. Positive, positive. So x equals plus or minus 2. So at x equals 2, they both have a value of 4. All right, yes, that's correct. At x equals 2, they both have a value of 4, 2, and -2. So at 2, I'm at 4, and at -2, I'm at 4. And the question is, what's the area enclosed by these two curves? All right, well, for this particular one, we see that the purple one is always above the blue one. All right, so Jordan will be very happy. I'm going to do a shortcut. These are both parabolas. Because they're both parabolas, we understand the symmetry. So the symmetry is going to tell us that it's 2 times this region right here. All right. So instead of going -2 to 2, oops, that should be positive, -2 to 2, I'm going to take the 2 times the integral from 0 to 2, upper, which is x squared, minus lower, 2x squared minus 4. All of that, that's my height, upper minus lower, that gives me my height, times my width, dx. Simplifying this is 2 times the integral 0 to 2, let's see, negative x squared plus 4 dx, which is 2 times negative x cubed over 3 plus 4x as x goes from 0 to 2. So this is 2 times negative 8/3 plus 4 minus 0 plus 0, so minus 0. Let's see, negative 16 thirds plus 8, and 8 is 24 thirds. Negative 16 thirds, no, plus 8 is 24 thirds. I'm supposed to get 32 thirds. Oh, put the 2 in here. This is 8. Okay, so 2 times 8 is 16. So this is 32 thirds. Negative 16 thirds plus 32 thirds. No, that's still not right. Slow it down. 2 times negative 8 thirds plus 8. 2 times 8 is 16 over 3 is 48. See, shouldn't do math without skipping steps, which gives me 32 over 3, and that's the correct answer, 32 over 3. All right, key idea here, upper minus lower. This particular one, I was able to do 2 times this. Now in the previous example, I wouldn't have been able to do that for this yellow region, right? Because it's not symmetric. It's not symmetric. So even though that parabola is symmetric, that region is not. So you have to be very careful when you decide to take the shortcuts. All right? Okay, so let's get rid of that one, get rid of that one, and we'll go up here to this one. All right, this time we're going to try using the calculator. All right, this time we're going to use the calculator, and I forgot to set it up early, so just give me a second. All right, so go ahead and put in your calculator. y1 equals x to the 5th minus 4x squared plus 1. And y2 equals 2x squared minus 4. Okay, purchase later. Okay. All right, come on, come on. All right, if you have those in your calculator, go ahead and graph them. All right, I've already put them in my calculator. Okay, so see, I've got y equals, my y1 is x to the 5th minus 4x squared plus 1. And y2 is 2x squared minus 4. Now I'm trying to find the region fully enclosed by these two functions. All right, when I graph these, all right, first of all, mine's in color. If yours is not in color, what you can do, what I often do, is I come down here and turn that one off and then push graph and get in my mind which one that is. All right, oh, I've got my window set 4 to 4, negative 4 to 4, and negative 4 to 4, so that you can see it better. All right, so that's my y1, and now when I go here, I come over here and turn on y2, enter. All right, so that I know which one's which. All right, so this what is shown as the blue one is y1, and the red one is y2. Now we've done this before. We're going to calculate the intersections. I've already done it, so let me just show you and get out of here. I calculated the intersections and labeled them A, B, and C. So alpha A is when x is negative 0.866. Alpha B is when x is 1. Just for consistency, I went ahead and left it in there as B. And alpha C when x is 1.5905. All right, so those are my points of intersections. They make sense. Negative 0.866, yeah. 1, yeah, and a little over 1.5, yeah, those make sense. Those are my x intersections. All right, so in the first section from A to B, y1 is on top, but in the second section from B to C, y2 is on top. So how are we going to calculate this area? Okay, what we're going to do is we're going to take math, what number is it, 9? All right, we're going to take the integral from A, let's go up, to B of, which one was it? It was y1, y bars, function y1 minus, that's my height, right? y1 minus bars, the one that was below it. Function, go down, y2. All right, so that's the height. And what's the width? The width is dx. All right, so that's the area between A and B. Now I need to add to that, Math 9, the integral from B to C. This time the upper is y2, vars, y vars, function, y2, minus vars, y vars, function, y1. This time, since y2 is above y1, the height is upper minus lower. The width is still dx. And it should give us a value, we hope, of 6.69 something. What is it thinking? 6.6905. So the correct answer would be 6.691. 6.691. Okay.